In this series, we're exploring scalability. Today's focus is on scaling your data environment to better serve end users, whether they're business analysts or individuals with limited data experience who, nonetheless, still rely on data-driven decisions. We'll highlight 4 foundational yet indispensable techniques: aggregation, filtering, column reduction, and change detection. And we'll demonstrate how simply and effectively these techniques can be deployed in Matillion DPC. This video is part of a series exploring scalable data architecture. If you haven't already, check out the accompanying blog post where we delve deeper into these concepts and their practical applications. Let's examine U.S. domestic flights from 2020 to August 2024. At the flight level, we're dealing with approximately 28 million rows. While this dataset is modestly sized from a data platform perspective, it's large enough to be unwieldy for reporting tools. Mastering foundational techniques like aggregation, filtering, and change detection is akin to blocking and tackling in American football. These basics may seem simple, but they form the bedrock of successful and scalable data platforms. A valuable technique is to create aggregated tables at different levels of granularity. Using Matillion's aggregate component, we can roll up our data to just 53 rows representing U.S. states and provinces. Alternatively, we might roll up to the destination airport level, where we have 406 rows of aggregate data. This approach enables us to use multiple datasets in reporting tools like Tableau. Some of these datasets are aggregated and some are detailed. For instance, while utilizing an aggregated dataset for a map, we can simultaneously work with detailed data. By clicking on a state like Texas, we filter the underlying 28 million row flight level dataset, improving performance by accessing only the relevant subset of data. This isn't just about performance, it's about empowering analysts to tell seamless, compelling stories with data. Retaining row-level granularity alongside aggregated data allows for flexible, multi-level exploration that meets various reporting needs. Next, let's explore filtering techniques. Working with our 28 million row dataset, we use a window calculation component to partition data at the destination airport level, summing flights for each airport. For perspective, O'Hare, ORD, one of the busiest airports in the US, counts for 1.1 million rows. This is followed by a rank component to partition data by destination state, assigning rank values to airports within each state. Next, we filter to show only the top 3 airports per state, creating our top 3 destination state table. In our reporting tool, we can see the resulting focus on the busiest airports where LAX and SFO are the 2 busiest airports in California. This type of approach creates a more focused dataset for analysis while maintaining low-level granularity. By curating the data experience for end users, we ensure the data remains actionable and intuitive. The rename component, while simple, proves quite useful. It serves not just for renaming, but also for removing and reordering columns. Here, the rename component removes the unnecessary columns from the original dataset, creating a streamlined, targeted fields dataset. In tools like Power BI, this makes a significant difference. While the original flights dataset might overwhelm some users, the targeted dataset remains manageable and user-friendly. Providing clear, well-structured tables helps enable all stakeholders, not just analysts, to perform quick and dirty research confidently. It's about empowering users to act on data, not getting lost in it. Finally, let's consider change detection. While Matillion fully supports change data capture, CDC, this process can be resource-intensive. For use cases requiring quick responses without extensive detail, we can use the SQL component with a focused query comparing 2 datasets to identify changed, new, and deleted records. The results can then be output to a table or view, providing quick, actionable analysis for end users. Simple SQL techniques like this allow analysts to gain insights quickly and stay agile, while full CDC solutions handle more complex scenarios. These 4 techniques, aggregation, filtering, column reduction, and change detection, are foundational to effective data platform management. While simple, they are essential techniques that encourage end-user interaction and should be prioritized in any data architecture strategy. By mastering these blocking and tackling techniques, You'll build a scalable, user-friendly data platform that empowers analysts and decision makers alike. For more details, be sure to check out the accompanying blog post. Together, these resources point to the foundations of a robust and scalable data environment.